Hello everyone and welcome to Pentagon. Today's problem is another logarithmic problem. If the log of the square root of 13 plus the square root of 3 is equal to a, we need to solve for the log of the square root of 13 minus the square root of 3 in terms of a. This has quite a creative solution, so please pause the video here if you'd like to try and solve this yourself. Alright, now before we start, just a basic review on logarithms. Let's say we have any exponential equation where we're raising a base b to an exponent k, and our result is the argument n. If we want to write this same relationship in logarithmic terms, we would write log base b of n is equal to k. You can also think of logarithms as the reverse of exponential equations. While in exponential equations we are solving for the argument, in logarithmic equations we are solving for the exponent. One tip before we start to work on the problem: if there is any expression like the log of n, we automatically assume that the base is 10. So log base 10 of n is the same thing as log of n. With that, we are ready to tackle the problem. Now, at first it may seem daunting to try to get from one expression to another. But what if we get a bit creative? What if we take these two expressions and we added them together? So we would have log of the square root of 13 plus the square root of 3 added to the log of the square root of 13 minus the square root of 3. Now, there is a very important logarithmic relationship that will be very useful in solving this problem, and it is log, and we'll take any base, let's call it x, log base x of a plus log base x of b is equal to log base x of a times b. And of course, since x is any base, this could obviously work with base 10. So we also have log of a plus log of b is equal to log of a times b. Alright, please leave a comment below if you want me to prove this in a future video, but I won't be proving it in this video. Alright, now, let's use this relationship to simplify the expression we've just derived. Using this as a and this as b, we can rewrite this expression as log of, in brackets, square root of 13 plus the square root of 3 multiplied by the square root of 13 minus the square root of 3. Now, this setup should look a bit familiar. This is actually a result of the difference of perfect squares. Now, when solving for the difference of perfect squares, this is the formula. X plus y times x minus y is equal to x squared minus y squared. Now we can use this formula and substitute in the values of x and y as the square root of 13 and the square root of 3. So we'll use the square root of 13 as our x and the square root of 3 as our y. And when we do this and we simplify even further, we get log of the square root of 13 squared minus the square root of 3 squared. Now what you might notice is that we're taking the square root of something and then squaring it. So those two just cancel out. So this simplifies to the log of 13 minus 3, which is just equal to the log of 10. Now, remember how we said that log of n is the same thing as log base 10 of n? Well, there is an invisible base of 10 here. And we need to solve for the exponent such that, and when we convert this back to exponential form, to our answer, let's call it k, is equal to our argument 10. Well, in that case, k is just equal to 1. So, we have that the log of the square root of 13 plus the square root of 3 plus the log of the square root of 13 minus the square root of 3 is equal to 1. But wait a minute. We have another value for this, for the log of the square root of 13 plus the square root of 3. From our first equation, this is equal to a. And we are asked to solve for this value in terms of a. Well, this is just completely simple. We have a plus the log of the square root of 13 minus the square root of 3 is equal to 1. So if we subtract a from both sides, we get that the log of the square root of 13 minus square root of 3 is equal to 1 minus a. Thank you for watching this video. If you liked it, please consider subscribing to our channel. Thank you all, and I will see you in the next video.